Okay, more tricks for evaluating integrals of sines and cosines. If we have a product of even powers of sines and cosines, and remember having no cosines, that counts as cosine to the 0th power, and that's an even number, the U substitution trick does not work. Instead, we must use the half-angle formulas. For example, here's a nice tedious problem, sine to the 4th of x. What do? Well, we break that up as to sine squared of x times sine squared of x, and we use the half-angle formula that says that the sine squared of x is 1/2 1 minus cosine of 2x. We put that in for each of the sine squareds, and we get the integral of 1/2 1 minus cosine of 2x times 1/2 1 minus cosine of 2x dx. Now the 1/2 times the 1/2 becomes 1/4, and we can put that out front. And 1 times 1 is 1, and we get minus cosine of 2x minus cosine of 2x minus 2 cosine of 2x, and then the negative cosine of 2x times negative cosine of 2x becomes plus cosine squared of 2x. Now, most of this is pretty easy to evaluate. Let's see. We have 1/4 times 1, the integral of 1 when x is your variable is 1x. For the, let's see, we have 1/4 out front, we keep the negative 2 right there. Whose derivative is cosine of 2x? Now you can do this with u substitution. You can say u equals 2x, du equals 2dx, and all that sort of stuff. But in a problem this big, it helps if you can start doing some really basic u substitutions in your head. You think, whose derivative is going to be cosine of 2x? It's going to be a lot like sine of 2x, except that the derivative of sine of 2x is cosine of 2x times 2, times the derivative of what's inside. So if we use sine of 2x times 1/2, that 1/2 is going to cancel it out. Let's look at this one more time. What's the derivative of sine of 2x times 1/2? Well, this is the 1/2 is a constant, you just leave it alone. The derivative of sine of 2x is cosine of 2x times the derivative of what's inside, which is to the 2, which cancels out with the 1/2. That gives you exactly what you want. And we're left with this thing with the 1/4 out front. Integral of cosine squared of 2x. Again, it's a trigonometric integral with an even powered. Boo. Right. So what do? We leave all this stuff alone. Let's see. 2 and the 1/2 cancels out. So we're left with x over 4 minus 1/4 of sine of 2x. And now what do we do with this thing? Hey. Now, the half-angle formula for cosine, and rather than say x, I say w, because it doesn't matter what the variable is. The cosine squared of something is 1/2 1 plus the cosine of double that. So the cosine squared of 2x is going to be 1/2 1 plus cosine of 4x. Some people call these the double angle formulas. I don't know, half or double, it depends on which side of the equation you look at first, right? Anyway, so you got the 1/4 out front, you've got the 1/2 coming in here, and the cosine squared of 2x becomes 1/2 1 plus cosine of 4x. And let's see, we leave these things alone. 1/4 times 1/2 is 1/8. The integral of x, because you can pull the 1/2 out front, the integral of x dx is just, so we have the 1/8 out front, and the integral of 1 dx is just x. Whose derivative is cosine of 4x? Here's one cool thing about the half-angle formulas. We're turning sines into blah 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 cosine, we're turning cosines into blah 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 cosine. So this whole do the u substitution in your head, it's always going to be with cosines. It's always the derivative of sine that gives you your cosines. The antiderivative of cosines don't have negatives in it. Kind of nice. Whose derivative is cosine of 4x? It's the sine of 4x times a fourth. That 1/4 is going to get rid of the derivative of what's inside when you take the derivative. You add your constant at the end. We can clean this up a little bit. 1/2 of 8 is x. 1/8 of x is 8 over x. And then the 1/4 and the 1/8 becomes 1/32. And the only other thing you can do is 1/4 x is 2x's over 8 plus 1x over 8 is 3/8 of an x. You got the 1/4 sine of 2x, and you got the 1/32 of sine of 4x plus c. Whew! This is why I said it was a tedious problem. And this is, in fact, the integral that we were looking for of sine to the 4th, all the way back. The problem is, if to verify this, we'd have to take the derivative of this and get this. And clearly we're not, unless we use the half-angle formulas again. So let's not do that. Let's just stop here. If you think this is tedious, just you wait. Later on in the semester, we are going to do tricks to get things to look like this. This is going to be, we are going to reach this point halfway through the problem, and then we're going to have to do all of this. So get good at it, and definitely become really familiar with your half angle formulas.